all of the analysis that we will discuss later on will go back to these concepts that we study today. Okay, so the first one is actually a concept of uncertainty. Okay, so what I want you guys to take home with you, one of the most important lesson in this entire class, actually, not just today, but this entire semester, is actually that every measurement will contain some degree of uncertainty. Ya, jadi setiap pengukuran pasti mengandung ketidakpastian. Okay, and because in our daily lives we will always encounter what we call random variables. Okay, so those would be the numbers, those would be the quantities or the variables that we cannot be certain about the value of until after we're done with the measurement. Ya, jadi variabel acak adalah besaran-besaran yang kita tidak bisa menentukan nilainya sebelum kita tidak bisa meramalkan nilainya sebelum kita melakukan pengukuran. Okay, that's why the reason why it's called random variables, right? And we have introduced to you this concept last week. Okay, sample versus population. So I'm going to skip that one. There you go. Okay, so this is one of the most central concept in statistics, that every measurement will contain uncertainty. Yeah. Okay, and we will revisit this concept again and again throughout the class. And actually, throughout your career as engineers, you should be aware about this uncertainty of measurements. Okay, so never ever be sure with data from just one measurement points only. Okay, and then the second concept is this one here. Okay, there you go. Let me highlight it in yellow. Okay, the 5 descriptors of data. So what we are about to do this morning is actually to take some very simple measurement data. Oh yeah, by the way, have a ruler ready by your side. Okay, penggaris, siapkan penggaris di sebelah kalian. Yeah. So any measurement data can be described by 5 descriptors. Ya, penciri data, and those are measures of central tendency, okay, ukuran kecenderungan pusat, measure of spread atau ukuran sebaran data, measure of distribution atau ukuran bentuk sebaran data, outliers, or the Indonesian term for it is pencilan, okay, and number 5, the last one, is temporal behavior. Okay, and the number 5 is only valid for time series data. So if you're taking your measurement with respect to time, then number 5 is valid. Otherwise, it's not. Okay, and on your right hand side here, okay, this is called a frequency distribution. Okay, so what this kind of graph is telling you is how many times does a certain interval value of data appears or observed. Okay, so in this case, this is a particle size. This is the measurement result of a particle diameter as done by graphic analysis, yeah, analysis citra. So what this researcher does is he or she takes a micrograph picture of something, suspension perhaps, and then the researcher then analyzes the size of these particles using computer software. So this is an image analysis approach. Okay, so based on that analysis, the researcher then construct this frequency distribution, yeah, distribusi frekuensi. So each the particle sizes are divided into certain numbers of intervals. Ya, jadi ukuran partikel ini dibagi ke dalam sejumlah interval atau selang. Ya. And those intervals are represented by these bars here. Okay, and the height of the bars tells you how many times or how many particles belong to a specific size interval. Yeah. So you do that for this entire photograph, and you come up with this we call it frequency histogram. So this type is called histogram. Yeah, and this tells you the shape of the distribution, where what particle size occurs the most, okay, with the highest frequency. In other words, what is the minimum and the maximum size, or the minimum of the maximum size intervals, and so on. Is the shape of the distribution symmetrical or not? So this is the characteristic. This is this is how you describe the data measurement. Ya. Jadi mendeskripsikan sebaran suatu data itu kita tidak sembarangan. Tetapi kita selalu menggunakan beberapa besaran penciri. Oke, penciri itu mencakup 5 ini. Ya, ukuran kecenderungan pusat or typical behavior of your sample. Okay, including average, ya, nilai rata-rata, median, and modus. Ya. The second one is ukuran sebaran data, measure of variation, shape of distribution, jadi bentuk distribusinya, outlier, whether we have data that behave abnormally or not, yeah, data that lies outside of the group, and then the number 5 is whether we have time dependency or not. Yeah. Okay, so this is very important because any statistical analysis will go back to here. Okay, for example, let's say that you have 2 pictures like this. Okay, 2 pictures like on the right hand side here, and you are asked to verify whether one type of particle have different particle size distribution with the other. Ya, jadi kalian diminta untuk membandingkan distribusi 2 buah partikel yang berbeda jenisnya. Ya. So how can you say that there's indeed a difference between these 2 different particles? So you have to go back to these 5 descriptors here. Okay, so we can say that 2 samples behave differently if their descriptors are different from one another. And by different meaning, we also have to take into account the uncertainty of measurement. So we always say, is it statistically different or statistically not different? So we don't just say different or not, but we say statistically different, which means that we take into account the uncertainty. All right, so whenever you guys, so you have your rulers ready. So again, this is a very, really simple assignment. Okay, so what I want you guys to do is measure. Okay, wait. Let me unblur my background here. Okay, so you guys can see my fingers more clearly. Okay, there you go. All right, so measure the length of your first, of your first segment, of the first segment of your right hand index finger. This one here. So this is my right hand index finger. So using a ruler, measure the first segment of your right hand index finger to a millimeter unit. Okay, so don't report it in centimeter, but in millimeter. Okay, don't think too much about it. Just do one quick measurement, and let me know what the numbers are. And I will write down the numbers on an Excel. I'm not going to write down your name, so this would be an anonymous measurement. Okay, and then we will see how your data looks like. Okay, for the entire class. Okay, so just open up your microphone, or I can call you up. Hang on a second. All right, so who's here? I'm just gonna read your name from top to bottom. Ahmad Al-Fadan. So what's the length of your index finger segment? In millimeter. Don't think too much about it. Just do a quick measurement and tell me. This works best if you guys don't think too much about it. Just do a quick measurement and tell me. So Ahmad, what is the length? You don't have a ruler with you? Oh, okay, 2.4. Yeah, 24 millimeter. Okay. One is Ahdan.
Good morning, sir. My right finger is 26 millimeters.
Okay, next one, Alika.
It's 23 millimeters.
23?
Yeah.
Okay. This is not including the nails, okay?
Yeah. Oh, okay. It's
Try as
12
much as possible
millimeters.
to avoid the nails. So Alika, what's yours?
It's 12, I think.
12. Okay.
Is it before the nails or?
Excluding the nails.
Oh,
No, you mean
excluding.
if you guys have extended nails, don't mess with that. But
Oh,
not this
it's
one.
2
Okay,
millimeters.
this one is included, of course. This one is included. Okay.
Oh,
So
okay.
if you guys have long nails, okay, don't measure that. Measure it from here to here. Okay, can you see my fingers?
Yeah, yes, sir.
Okay, roughly.
It's 2 millimeters. It's 20 millimeters.
Okay. All right, thank you. Next, Arvin.
28.
Aurel.
23, sir.
23. Okay, Azra.
27, sir. 27.
Okay. Cherry.
27 too, sir.
27. Dimas, what's yours?
28, sir.
Okay. Emeralda.
27, sir.
This is not a contest, you guys, okay? So just report to me whatever number you come up with, okay? Evan?
28, sir.
Gama? 'Kama? Okay, Gama, what's yours? Where's Gama? Oh, you can type it in the chat if you're having trouble with your microphone. Okay, got it. Right, moving on. Keraldi?
27, sir.
Yep, okay. Kifari? If you're having any trouble with your microphone, just type it in the chat box. It's okay, or message. Okay, Kifari, what's the number? 27, all right. Thank you. Waradana?
28, sir.
It's okay if it's different, okay? Even though there's a lot of different of average, of course. Ilham?
It's 24 millimeters.
All right, thank you. Jilan? What's yours?
26 millimeters, sir.
You. Jinan?
23 millimeters.
Yes?
It's 23 millimeters.
Don't think too much about it. Just measure it and tell me.
Yeah.
Okay, got it. Joshua?
It's 28 millimeters, sir.
Thank you. Karunia?
23 millimeters, sir.
Thank you. Kasia?
24 millimeters, sir.
you. Lintang?
It's 20, sir.
21?
20, just 20.
Lydia?
24, sir.
Thank you. Masaya?
Mine is 26 millimeters, sir. Also, I apologize for not turning on my camera. It says here that no available camera found. Thank you, sir.
Yeah, okay, that's all right. Muiz?
26, sir.
Okay. Hadian? Hadian, what is your measurement?
28 millimeters, sir.
Thank you. Kanzu, Muhammad Kanzu.
26, sir.
21?
56.
I can't hear you. Your voice is muted. Okay, got it. Thank you. Raikul.
23 millimeters, sir.
Thank you. Raka?
26, sir.
Ulaya, what's yours?
24, sir.
I think that's it. Oh, last one, Yasmin. You can write it, Yasmin, if you have trouble with your microphone. Okay, got it. All right, so I got all of your numbers here. Oops, sorry. Okay, let's see how it looks like. All right. Okay, now let me share you the raw data. Okay, let me share you what your data looks like in its purest, in its most crude form, dalam bentuk yang paling mentah. Okay, so this is the data. This is the measurement of your the first segment of your index right hand finger. Okay, so there are 30 of you. Okay, and now if I'm giving you guys these numbers, okay, as it is, without any calculation, without any data treatment whatsoever, then it will be hard for you to draw any conclusion on this, right? Well, if you glance, if you take a look from top to bottom, bottom to up, and so on and so forth, you can probably guess that, okay, the numbers 27 and 28 occurs more times, occurs more frequently than other numbers, perhaps. Okay, but that's not giving us much information to work with. Okay, so for example, let's say that you guys are developing some product. Okay, maybe some device that has to be fitted on your fingers. Okay, I don't know, maybe some safety device, or you're designing some piece of equipment that requires the size of finger segments. Okay, so if you need to make any decision about the design of the device, of the component, then you need the numbers, right? You need the size. What is the average size or average size of finger segments of Indonesian students? Okay, so these numbers alone won't do you much good. You have to do something with these numbers. Of course, maybe the first thing that pop into your head is probably, okay, let's calculate this average. And that is valid. That is one valid analysis, of course. So we can, for example, we can calculate the average, right? The average length. And, just simply use that Excel formula here, right? Average and like that, for example. Okay, I'm just giving you a very easy example. Okay, so the average length of your finger segment is 25.37 millimeter. Okay, so this is one data descriptor. Yeah, Jadi yang saya lakukan di sini, saya menghitung rata-rata panjang ruas jari kalian, ya. Ini adalah satu cara untuk melakukan analisis deskriptif, ya. So the average length is one example of data descriptor, besaran penciri data. Nah, dalam hal ini apa yang dicirikan? Yang dicirikan adalah kelakuan umum. So this is a measure of central tendency of your population. Okay. This means that if I were to pick one of you randomly, okay, or if you guys are adding one more student to your group, okay, and I'm measuring his or her finger segment length, then I can expect that the number will not be far different from this one. It will not be significantly different from 25.4. Okay, so that's one descriptor. The other one, perhaps the other thing, if I ask you guys to describe to me the width of variety, jadi seberapa lebar variasi data ini, okay, so you might come up with something like standard deviation, right? Simpangan baku. We will, again, we will discuss a lot more about this in terms of how to calculate this, or you guys already familiar with how to calculate standard deviation, I suppose. Okay, so in Excel, you can use this one, STDEF, and then highlight the data range. Okay, just hit enter and you get the number. Okay, so this number tells you, gives you an idea of how narrow or how wide the distribution of your finger segment length. Okay, now let's do some more cool stuff with your data here. So let's construct some graphics out of it. Histogram. Whoops, what is this? Sorry about that. Insert. Oh. There you go. I'm supposed to highlight the data first, am I? Histogram. This one. Quickly out. Format data series. I want to change this one actually to format axis, number of pins. I want 5 pins, for example. Okay, so this is the size distribution of your finger segment. Okay, so it's and well, this is not a very good. Let me change again. Number of pins. I want it to be, let's say, 8 pins. Okay. Right, let's do this correctly. So axis title, primary horizontal, add, go, in millimeter, then vertical, that's frequency. Frequency meaning how many times these numbers are observed. Okay, so this is your what your data look like. Yeah, as you can see, each bar represents one interval. Yeah, mewakili satu selang. So for example, the left hand side most segment here. This is the 20 to 21 millimeter segment. This is 21 to 22 millimeter segment, and so on. So you can see that looks like your population is divided into two groups. So this one here and this one there, and so there's a you guys can be your characteristics can be divided into two separate groups. It looks like, okay, so one here and one there. And then you can see that the lowest value is about 20, the highest value is 28. Okay, and that the distribution is not symmetrical. Okay, it looks something like this. Okay, so more people in your group have their finger segment length here than on the left hand side there. Okay, so we can say that the distribution is not symmetrical. Again, this is a very simple measurement, and this tells you how you can describe the data using descriptive statistics. Okay, so this is what you will learn in this chapter. Okay, now Bu Winnie has already uploaded the links to 3 YouTube videos. Okay, so what I want you guys to do now is to watch those videos and then go back to the class to discuss what you have seen. Let's see. There are 3 videos. The length, I think, is about, the total length is supposed to be about only 50 minutes. Okay, so you can watch those.
Pak Wamsi, actually there are 4 videos. If you can see the learning video in module 2, there is 3 videos from Bu Helen and 1 video about tutorial penyusunan grafik ya from you, Pak.
Yes. Okay. For now, you guys can skip the last one. Okay, just skip the demo video. You can learn about, you can see that later on at your own leisure. So watch segments number 1, 2, and 3, the one with Bu Helen in it, not the one with me in it. Okay. So go ahead and watch those. In sequence, and I will give you guys 20 minutes. So we will meet at 7:55. Well, make it at 8. So we'll meet at 8 to discuss what you guys have seen. Okay, Bu Winnie, any further instruction from you?
No. How about everyone? Can you have everyone have access to EduNext? Yeah, can everyone access and then see the videos in the module 2, descriptive statistics, and then look at the submodule learning videos? Okay, everyone's good. Please raise your hand if you haven't seen the videos or if you have trouble to access the videos, please.
Yeah, just let us know if you guys have any problem with the videos.
Yeah, Evan, what's your problem?
Yes, Miss. I don't see the video in. Wait.
Go to the module.
I already found it. Thank you.
Yeah, learning videos, and then check it if can it be played or not. I think it should be. Yeah.
Yes, I can play it. Thank you.
Okay. All right. Maybe okay, Pak Miki, 20 minutes or 30 minutes?
Yeah, we'll meet again at 8. Yeah.
Yeah. Okay. Module 2, yeah, Ahmad. Please go back to module 2.
Winnie, Ilham is having trouble with the token.
Yeah. Okay. The token is module 2. This one, the token, is it expired? The token? Wait. Okay, I'm gonna make it again. Okay, just Token expired. Oh, it's not expired.
Okay.
Okay, Ilham, that is the token.
Hmm? Okay, how's everyone? Hopefully you guys can enjoy the videos. Okay, right. So let's go back to our PowerPoint. But I'm going to show you the video segmentized version of the PowerPoint. Now I do apologize that this one is in Indonesian. You already have the English version, but the full version of the PPT. So what I'm about to show you is the segmentized version of the PPT, although it's written in Indonesian. Hopefully you guys can still see the data and follow it. Again, we have already uploaded the English version, so I'm showing you the Indonesian version because this one is already segmentized. Okay, so this one is exactly what you see in the video. Okay. All right. So in the first segment, we discussed the concepts of populations, sampling, and also random variables. I think this is pretty much very well described. So now I'm just going to ask you guys, do you have any question, anything that you don't understand about the concepts of population and sampling, also random variable? Any questions here? Oh yeah, by the way, if you have any question in the Microsoft Teams, just feel free to open up your microphone and just interrupt me, because in this mode I cannot see if anyone is raising hand. Okay, this is the difference between Teams and Zoom. Okay. Okay. Any questions here? No. Go ahead.
Can I ask a question?
Sure. Go ahead.
I'm still not clear between the difference between physical population and conceptual population.
Okay.
Can you give an example? Thank you.
Yep. Okay. Thank you. Yeah. So actually, this one I need to go back to the original English version of the PPT actually, because there's more explanation about that in this one. All right. No, okay. All right. So in a physical population, we can define all of the members of the population. Okay. So each and every member can be identified. They can be defined. Okay. This is an example. So if the population is the citizen of Indonesia, yeah, then we say that it is a physical population because we can clearly define who the Indonesian population are, right? Jadi gini contohnya, I'm switching back and forth between English and Indonesian, okay? Sorry about that. Jadi populasi fisik itu cirinya adalah anggotanya bisa didefinisikan, ya. We can clearly identify each member of the population, of a physical population. Ya, jadi kita bisa mengidentifikasi siapa saja anggotanya atau apa saja anggota dari populasi fisik ini. Ya, contohnya adalah populasi Indonesia. Okay. So when we say who the Indonesian population are, the sample is clear. So this would be any citizen that holds Indonesian KTP, okay, or if they are still below age, okay, if they are still below legal age, they are born in Indonesia, right? Jadi definisi dari anggota dalam tanda kutip populasi Indonesia adalah siapapun yang punya KTP Indonesia atau bagi yang masih usianya masih di bawah umur yang lahir di Indonesia. Jadi inilah mereka yang diakui sebagai WNI, ya kan? So even though the number is very large, let's say, I don't know what's our population now, I think it's 250 million perhaps. Okay? So it doesn't matter how large the population is, as long as you can identify each member uniquely, yeah, then it is a physical population. Ya, jadi dalam hal Indonesia ini, meskipun anggotanya banyak ya, sekitar mungkin sekarang sudah sekitar 250-an juta orang, ya, Tapi kita bisa mengidentifikasi setiap rakyat Indonesia, ya. Namanya siapa, KTP-nya nomor berapa, ini kan unik ya. Jadi setiap orang rakyat Indonesia itu unik, tidak ada cloningannya, ya kan? Tidak ada kembaran pun juga KTP-nya beda, ya kan? Nah ini artinya setiap anggota bisa diidentifikasi secara unik. Ini adalah ciri-ciri dari populasi fisikal. Now, what about conceptual population? In a conceptual population, we cannot identify each member. Now, please emphasize the word each member. Okay, in a conceptual population, we cannot identify each member uniquely. Okay, now let's see this example here. Yeah. Okay. Oh no, sorry. Go back. This one. Okay. So let's say that you're measuring the length of this bolt. Yeah, and so somebody is giving you this is things where it gets this thing gets a little bit fuzzy. Okay, let's say that I'm giving you a box containing 100 bolts. Ya, saya kasih kalian 1000 maaf, saya kasih kalian satu kotak isinya 100 bolt, 100 baut. And I'm asking you, and I'm telling you, hey guys, this is the population. Okay. This is me telling you that this is the population, okay? So from your point of view, this is a physical population because you can identify each and every member of that 100 bolt in one box. This is because Pak Walmik is telling you that this is the population, okay? So this becomes physical population because you can identify each member, okay? But now, imagine yourself, you're working in a factory that produces these bolts. Ya, sekarang kalian bayangkan kalian bekerja di perusahaan yang memproduksi baut ini. So in one day, perhaps your company produces millions of this stuff. Okay, maybe 1,000. Well, maybe not millions, but thousands. Let's say that your company produces 1,000 bolts per day. Okay, jadi pabrik kalian memproduksi 1.000 baut per hari. Ya, nah, sorry about that. So for practical purpose, okay, is it necessary to measure the length of each and every one of those thousands of bolts? Maybe not. Okay. So then the problem becomes no longer a physical population because you don't need to identify, and in fact, you cannot practically identify each and every single bolt if your production scale is thousands in a day. Ya. Jadi kalau sekarang kalian meninjaunya ya dalam satu pabrik yang memproduksi bolt ini dalam skala ribuan per hari, ya. Secara praktis kalian nggak mungkin mengukur satu persatu, ya kan? Ya kecuali mungkin kalian punya alat yang memang betul-betul canggih gitu ya, instrumen otomatis yang bisa mengukur panjangnya. Tapi let's say kalian nggak punya alat itu, ya. Nah, untuk kepentingan praktis nggak mungkin kalian mengukur panjangnya ribuan bolt setiap hari, dan nggak ada gunanya. Okay, so it's impractical. It's impractical. It's possible, so we're not gonna do it. So now the problem changes from a physical population into conceptual population because you cannot identify each member of the bolt, you know, for the thousands of bolt every day, and that's only just talking one day. If we're talking about 1 week or 1 month of production, then or a year of production, then we're talking about millions of bolts. So there's no use to treat this as a physical population. Instead, we treat this as a conceptual population. The difference between crucial difference between physical and conceptual population is in a physical population you can do a census. Ya, jadi dalam populasi fisik kita bisa melakukan sensus. Sensus itu adalah proses pengukuran setiap anggota. Jadi kalau namanya sensus penduduk Indonesia, so each and every KTP holder is being measured, diwawancarai, didata. Bapak Ibu anggota keluarganya berapa? So how many kids, how many children are in your family? What is your occupation? What is your age? What are the ages of your family members? Let's see what else. The typical occupation, age. So those would be the the primary data that the government takes during census. So underline the word, in a census, you have to measure all of your population members. If not, it cannot be regarded as census. Okay. Now going back to our bold example, if I hand you a box containing 100 bold, of course you can do a census. Okay, as long as you call it and I call it as a population. Ya. Jadi dalam contoh baut ini, misalkan kalian dibatasi, oke, saya kasih kalian satu kotak isinya 100 baut. Ini loh, ini adalah populasinya. Maka kalian bisa memberi label. Oh, ini baut ini saya kasih nomor 1, nomor 2, nomor 3, sampai nomor 100 di dalam satu kotak. Tapi kalau kalian berurusan dengan pabrik baut yang memproduksi ribuan baut per hari, nggak ada gunanya memperlakukan itu sebagai populasi fisik. Kita perlakukan sebagai populasi konseptual. Kita tidak mungkin memberi label semua baut. Gitu. Kalau produksinya jutaan. Nah, gitu. Jadi kita tidak bisa melakukan sensus untuk populasi konseptual. Okay. Now, let me give you another example, and this one is actually very much relevant to chemical engineering. Now, take a look at the flow diagram that I'm presenting now. Okay. This is a typical what do you call it? Sampling port for oil and gas production. Okay, this is a sampling system, and this is usually installed in an upstream gas production. Ya, jadi produksi migas hulu, not the one in refinery, but the one in the fields, in the gas fields, in the lapangan gas or lapangan minyak. Okay, so some of the variables that they measure daily on a daily basis is, for example, how much water is contained in the fluid coming out of the well, of the gas well or from the oil well. Okay, so here they have this equipment called separator, phase separator, pemisahan fasa, and in this one particular case, this is a 3-phase separator. So this is the fluid coming out of the well. Okay, so this is a mixture of oil, condensable hydrocarbon gases, and also water. Okay, so this fluid, this mixture of materials is then separated in this equipment, which, this is really just a hollow tank with some valves and some ports, okay, some flanges, connections. And here you can see that the top one, this one is contains gas. So this one contains hydrocarbon gases. Okay, the brown one, this contains liquid hydrocarbons. We call it oil. Okay, or condensable hydrocarbon gases, hydrocarbons, and the blue one contains water. Okay, so each day an engineer that works in these oil and gas facilities, they have to check. Okay, so during a sampling, they have to check how much gas is being produced, how much liquid hydrocarbon, and how much water is being produced by the well. Okay, so you can easily imagine that it's pointless, and in fact, it's impossible to define the identity of the population members in this case. Ya. Jadi dalam kasus ini, kalau kita melakukan samplingnya setiap hari, kita nggak mungkin melakukan sensus. Kita tidak mungkin mengidentifikasi mana anggota populasinya. Let's say that you're sampling, again, you're focusing on the amount of water that is contained by the well fluid. Ya, jadi fluida yang keluar dari sumur minyak atau sumur gas ini mengandung air berapa banyak. So let's focus on that, how much water is contained. Okay, that quantity, you cannot perform the census of the amount of water, and the reason is because there's an infinite number of population members, right? You can this well is producing continuously, right? Jadi sumur minyak ini kan berproduksi secara kontinu, ya. So if you define, again, the variable of interest as being how much water is contained by the well fluid, that number belongs to conceptual population. Because at any given time, you can measure and you can get any number. Right? Jadi tiap kali kalian mengukur, kalian bisa mendapatkan angka berapapun. Kalian tidak bisa mendefinisikan, oh, anggota populasi yang namanya kadar air fluida sumur minyak ini ada berapa angka? Nggak bisa. Jumlahnya adalah tidak terhingga. There's an infinite number of population members because this variable is a continuous one. It is not a discrete one. It is a continuous variable. Yeah. I hope that gives you some idea of the difference between, physical and conceptual population. Is that clear enough? Jadi sebetulnya banyak sekali, ya. So banyak sekali hal-hal yang kita hadapi sebagai chemical engineers itu sebetulnya adalah populasi konseptual. Ya. Very simple case. I think I have mentioned this in last week's lecture. Okay, let's say that you guys are performing reaction in a test tube, tabung reaksi, and you are asked to calculate how much raw material, how much reactant, how much reactant is converted into reaction product, right? We call that fractional or molar conversion. And you guys have answered it correctly in the last meeting. That number, the lower value of that number is 0, which means that no reaction occur at all. The upper limit is 100%, meaning that all reactant is consumed, is converted into product. Okay. Now, between 0% and 100%, you can get an infinite number, right? You can get 10%, you can get 15, you can get 20, 75, 99.6, whatever. So you can get an infinite possibility of results between 0 and 100%. You cannot pinpoint the identity of the member of the population. So we call it a conceptual population. Okay. One thing for sure, one thing to ascertain, if you want to make sure to yourself, if what you're dealing with is physical or conceptual population, try to imagine if it's possible at all for you to perform census or not. Ya, jadi kalian bayangin aja, contohnya dalam besaran yang saya tampilkan ini ya, kalau kalian tertarik untuk meninjau kadar air dari gas yang keluar dari sumur, ya, mungkin nggak kalian melakukan sensus? Itu aja, kalian pikirkan ya. Kalau nggak mungkin melakukan sensus, artinya ini adalah populasi konseptual. Ingat, sensus artinya kalian harus berhasil mengukur, bukan hanya mendefinisikan, tapi kalian harus bisa mengukur semua anggota populasi yang mungkin terjadi. So if the number of population member is infinite, then you have to perform an infinite number of measurements to do a census on that. Okay, so that really answers the question, I think. Okay. All right. Any other questions? If not, let me go back to the Indonesian version of the slide because it looks nicer. I think Bu Helen already made the English version of her videos, but I forgot to ask her, so I'm giving you my version, which is in Indonesian. Okay, but again, you already have this English version and you upload it in your EduNext anyway. Okay, so all right, let's go back here. There you go. Okay, so what is descriptive statistics? Yeah. So what you do in this segment, in this chapter, actually is simply to describe the data. Now imagine that you're seeing this bunch of people here, right? And one of them is your friends. Okay, and I'm asking you, okay, so please describe what your friend looked like. So if you're asked that question, then of course, automatically, you will not be giving me a random number, but you're describing your friend to me in terms of specific parameters, right? For example, what is the color of her hair? Is her hair black or blonde or red hair, whatever? Okay. What is the color of her clothing on the day that you saw her and you described to me? Is she wearing a green shirt or a purple one or white or whatever? Okay. What is the height of your friend? Is she tall or medium or short? Okay. So, and several other parameters that you can talk to. Okay. So anyway, the bottom line is that when we describe data, we always describe them in terms of specific numbers, specific descriptors. We don't go about this randomly, but we always do this using certain numbers, certain parameters. Okay, and those parameters we call data descriptors. Yeah. Okay, and the first one again, this is the measure of central tendency. This gives you the general idea, the general behavior of the data that you measure. Yeah, kelakuan umum, or we can call it also expected value, nilai harapan. Yeah. If we sample, if we pick a sample member randomly, then what is the value that we can expect to measure? Okay, and there are three very commonly used measures of central tendency. Again, these three variables, these three numbers, all of them are measures of central tendency. So we have average or mean, median, and mode. Okay, and please take a look at your notes about how to calculate them, what their definition is. Okay. All right, and next one we have measure of spread or measure of variation. Okay, so this tells you how narrow or how wide your data is spread. Okay, as you can see from the data that we measured this morning. Okay, the spread of data of the length of your finger segments is, well, it's medium. I wouldn't call it very narrow. I wouldn't call it very wide either way. So for example, where is your number here? Okay, so the standard deviation of your finger segment length is 2.4 millimeter. Okay, so standard deviation is just one of several indicators of data spread. Yeah. There is my, wait, there you go. Okay. So again, if we're talking about variation of data, then we have three of these commonly used numbers. We have range or jelajah or rentang, which is the maximum value in a sample minus the minimum value of in the sample, and then we have standard deviation, simbangan baku, and also we have variance. Mathematically, variance is just standard deviation square, okay, sigma square. And then this one you probably never heard of before, IQR, interquartile range. Okay, interquartile range is third quartile minus first quartile. What is quartile? Please do your own research. Okay, so because this is an active learning environment, so we expect you guys to be curious. Okay, so if you hear the word, for example, quartile, what is quartile? Okay, so you can search that in the internet. Okay. All right. Next one, the third parameter or third descriptor is the shape of distribution. Okay, and this include, for example, how many peaks are there in the probability distribution or in the frequency distribution. Okay, if there's only one peak, we call the data unimodal. If it's two peaks, we call it bimodal. More than two peaks, we call it multimodal. Ya, jadi dia punya lebih dari dua moda, punya lebih dari dua modus. Okay. Remember, modus adalah nilai yang paling sering muncul. Okay, the value that occurs most frequently, we call it the mode. And then kurtosis tells you how sharp or how dull the peak of your distribution is. Okay. Plerichotic means that the distribution is dull, jadi puncaknya tumpul. And leptokurtic means that the distribution peak is sharp, and mesokurtic is somewhere in between. Okay, so that's kurtosis, the sharpness of your distribution peak, and then skewness tells you how symmetrical your distribution is. Yeah, skew means ekor, mengekor kemana? Okay, so positive skew, or some people call it right skewed, skew ke kanan ya. Right skewed meaning the data is elongated, the distribution is elongated to the right. And left skewed or negative skewed meaning the data distribution is elongated to the left. Okay, or to the negative value. Yeah. Okay. And here you can see that if we compare the three measures of central tendency, yeah, of course, mode is always refers to the peak of the distribution curve, ya. Ya, jadi modus itu selalu mengacu pada puncak distribusi. This one here. So, for example, in this data here, so the mode is here, it's located here, right? Okay, and then the median is the value of data that divides the value of measurement that divides your data set into two equal parts when you order them from the lowest to the highest values. Okay. Now, if your data is perfectly symmetrical, then the three numbers, the three measures of central tendency, which are the mean, median, and mode, they all lie on top of each other, like this. This happens if your data is perfectly symmetrical. Okay. Now, if your data is skewed, you can see that the value of mean is more sensitive to skewness compared to median. See that? Okay. So if your data is left skewed, for example, the mode is here, but the mean is pulled furthest. Okay, so the mean is pulled furthest to the left. So mean is more sensitive to skewness. Ya, jadi nilai rata-rata itu sangat peka terhadap skewness, terhadap ketidaksimetrisan distribusi. Okay. So that's why we call if there's a small number of students, maybe one or two students in your class, which is exceptionally smart, okay, so and their grade are much higher than their peers, we call them perusak rata-rata kelas. Okay. Anyway, the next one is outlier. Okay, so outlier are data point or data points. Okay, so it could be singular or plural. Yeah. So outliers are data points that deviates significantly from their group, ya, menyimpang jauh dari kelompok. Okay, like this one here, or this one here. Okay. Next one, this would be variation with time. Okay. Again, this one, temporal variation only applies if your data is a time series data. If not, then this last one doesn't apply. Okay. All right, and I'm moving on. I will move on to the last PowerPoint. Which is this one. Now, this one takes experience. Okay, there's no way around it when it comes to the proper use of graphics. Then you guys need to revisit these slides and also the demo, the Excel demo that Buwini has already uploaded. So please revisit those as often as you can, because there's nothing trivial about proper graphics. Okay, proper graphics is an essential engineering communication tool. Yeah. Okay. And when we talk about graphics application in engineering, don't automatically imagine infographics. Okay, so infographics has a lot of aesthetical value and a lot of marketing value in it. So in engineering, we generally we don't really use infographics that much, okay? Because it is potentially more misleading than technical graphics. Ya, jadi ya saya tahu generasi sekarang sudah sudah sangat terbiasa bekerja dengan infographics ya. Tetapi kita di engineering itu sebetulnya kita tidak terlalu suka dengan infographics karena kecenderungan untuk misleadingnya lebih tinggi daripada just a simple engineering graphs. Okay. So and the examples that I'm showing you in the video and also in the PowerPoint here, these are examples of engineering graphics. As you can see, they're simple, they're straightforward. Okay, no gimmicks. Ya, jadi nggak ada gimmicksnya, nggak ada gambar-gambar karikatur apanya gitu ya. Okay. And really, again, the reason why we use graphics is that it is a very compact and easy to understand format of data presentation. Okay, and it enables us to identify if there's any correlation between data. Okay, if there's any correlation between X and Y like this. Okay, this one is actually from my paper. Okay, this data, as you can see, this contains these bars. These bars are called error bars. Okay, batang galat, and these error bars tells you the uncertainty of measurement of these variables. Okay, so in one graph, the reader can not only look at the average of the measurements, but they can also they also get an idea about the level of uncertainty of these measured variables. Okay, and this is by the way, this is a measurement of charcoal yield from biomass. Okay, so we combusted some biomass in the lab, and then we calculate the yield of charcoal. Jadi berapa banyak arang biomasa yang kita peroleh dari setiap pembakaran biomasa tadi. Okay, and we do this in several batches, so we can calculate the uncertainty. We will show you in a few weeks how to calculate that. Ya. Jadi di sini seorang pembaca bisa melihat, oh ternyata kulit pisang ini ketidakpastian perolehan arangnya lebih besar daripada tandan sawit. Nah, gitu ya. Okay. Okay, I think this one, I've already shown you this one. Okay, histogram frequency. Now you might have noticed when I show you how to construct histogram for your finger segment data just this morning, some of you might have noticed that I changed the number of bars. Ya, mungkin kalian sudah memperhatikan tadi pagi waktu kita bermain-main dengan Excel ya. Nanti silakan dilihat lagi kan semuanya direkam oleh Bu ini ya. Bahwa saya mengubah-ubah jumlah interval. Istilahnya di Excel bin. So I changed the numbers of bins. So originally Excel gave us 3 bins, and then I changed it to 5, I think, and then I increased it again to 8 bins. So bins are other words for intervals. Okay. Now, the most critical aspect of constructing a frequency histogram is the number of bins that you want to draw. Ya. Jadi paling penting di sini adalah berapa banyak interval yang mau kalian gambar. Oke. Ini data yang sama. So this is one set of data, but it is being drawn with 2 different number of bins. Okay. The left-hand side contains 5 bins. The right-hand side contains 10 bins. Yeah. Now, take a look at this in greater detail at your own leisure and think for yourself. Okay, what do you think about these 2 graphs? Are they telling you are they telling you different informations, or are they implying different informations? Are you guys getting different impressions when plotting this way or this way? Okay, and please correlate that to data descriptors. Okay, by now you're already familiar with measure of central tendency, measure of variation, shape of distribution, and so on. Okay. Yeah. So this is a self-learning task for me. Again, take a look at these in greater detail later on and see and judge for yourself what are the differences implied by these 2 graphs. Remember, these 2 graphs refer to the same data. So they are drawn from the same data set, but are they giving you the different impression or not? Okay. All right. Next one, we have a Pareto diagram. Yeah? A Pareto diagram is just like histogram, frequency histogram, but it is ordered. Okay, so the bars, the bins are ordered from the one with the highest frequency to the one with the lowest frequency. This one here. Okay. Well, some people invert it, so from lowest frequency to high frequency doesn't matter. Okay. But anyway, the point here is that it is being ordered. Okay, in terms of the level of frequency. Yeah. And the bins are typically in a Pareto diagram. The X variable are categorical variable. Ya, jadi besaran X-nya ini adalah besaran kategori, besaran kualitatif. Ya, dalam hal ini, dalam contoh yang saya tampilkan di sini, so these are measurement of faulty components. Ya, komponen yang bermasalah. In a batch containing 1,000 pieces. Okay, so from each batch containing 1,000 pieces, we inspect the components and we calculate the number of each defect mode. Ya, jadi dari 1.000 keping sampel itu, dari 1.000 keping produk itu, jadi ini satu sampel isinya 1.000. Ya, perhatikan bedanya jumlah sampel dengan ukuran sampel. Jumlah sampelnya berapa? Jumlah sampelnya 1. Batch sampelnya, sebentar, sorry saya cek dulu biar saya nggak salah ngomong ya. The number of components, the number of faulty components per batch of sample. The N is 1,000. Okay, got it. So this one is from one sample containing 1,000 parts. Okay, so N refers to the size of sample, not number of sample. Ya, di kuliah statistik ini kalian coba untuk usahakan membedakan antara jumlah sampel dengan ukuran sampel. Ya. Ukuran sampel adalah pada saat kalian mengambil cuplikan, itu anggotanya berapa? Oke. Sementara jumlah sampel adalah berapa sampel yang kalian ambil, bukan berapa anggota tiap sampel. Oke. This can be misleading a little bit, and this may sound trivial, but in some calculations, you need to be able to differentiate between those two. Okay, number of samples and size of sample. Yeah. Okay, so here in our particular example, the number of sample is just 1, but the sample size is 1,000. Okay, so what we do from this one sample containing 1,000 parts, we identify the types of defects appearing in the samples and how many times they appear. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 defect types. Jadi kita punya 10 jenis cacat dari produk plastik ini. Ya, ada 10 tipe cacat. Kemudian kita hitung setiap jenis cacat ini munculnya berapa kali, gitu. Dan ini kita urutkan dari frekuensi tertinggi sampai frekuensi terendah. Ya. Di sini adalah jenis-jenis cacatnya. Jadi, so for example, warping. Okay, so warping is the most frequently occurring type of defects, which occur at a frequency of 23. Yeah. The second most commonly occurring defect is wet lines, and which shows up at 19 times, and so on. And the least frequently occurring problem is this one here, vacuum void. So vacuum voids occurs only 3 times in this one batch of 1,000 pieces. Okay. And now, also frequently in a Pareto diagram, we overlay this cumulative frequency polygon, which is called an ogive. Okay. Okay. A Pareto diagram is frequently used in management, okay, in problem solving, because this enables you to eliminate, to first attack the most problematic sources. Ya, jadi diagram Pareto ini banyak digunakan dalam manajemen, dalam perbaikan proses, karena dia memberikan informasi mana saja permasalahan yang harus diserang duluan. dan mana yang tidak perlu diprioritaskan. Ya, mana yang penting dan mana yang nggak penting, berdasarkan gitu. Okay. The next one here, you can read about it on your own. There's also an explanation of this in the video, so it's all there. I'm not going to highlight that for now. XY diagram. This is perhaps one of the most important type of graphics, so be sure to be familiar with how to construct an XY diagram in a proper manner, which means it includes everything, okay, including the axis title, the proper labeling, proper setting of axis length, and so on. Okay. Again, an XY diagram is one of the most important graphic type of graph that you will encounter. There's so many problems in chemical engineering that requires this kind of plotting. Okay. This one you might not be familiar with for now, but I can tell from my own experience. Okay, so after I graduate, after I finished, well, when I'm almost finished with my S3 study in the US, I signed up for a company. So I worked for 2.5 years in a company in the US called Corning Incorporated, and it happens to be that I was assigned in their statistical analysis group. Okay, and right there and then, so I learned about this this thing called box and whisker plot, okay, or some people just call it box plot. Okay, and actually, even though we in engineering doesn't use this type of plot too much, but actually this is very popular in the business side of things. Okay, so again, read about this on your own, and again see the video and pay attention to specific features that a box and whisker plot can offer you. This is a very compact type, a very powerful type of plot. It's for reasons that are unknown to me. They are not that popular in engineering, but they are very, very popular in business and management. Okay. Okay. Any questions here now about this topic? Now, before I'm closing this chapter, Bu Winnie has already uploaded the material for next week. Okay, so everything's there. The PPT is there. The videos from Bu Helen is also there. Again, because this is in this WFH setting, we want you guys to be a more active learning. So it is always very good for you if you watch the videos beforehand, even before the class. So between now and next week's session, it is always good for you guys to take a look at the video in advance, read the PPT in advance. Okay, so everything's already uploaded. Yeah. Any questions? Now, if not, I will close down this session with this pretty interesting picture. Yeah. This was drawn in the 19th century, actually. So this is probably the oldest type of infographics known to man. Okay. This is to give you an impression of how concise, how dense an information can be contained in graphics. Okay, and the importance of constructing a good graphics for your presentation, for your report. Okay, to convey engineering data. So this actually this chart is a combination of several information together. Okay, so this describes the attempt by Napoleon Bonaparte to invade Russia. He tried to invade Russia in 1812, 1813, and this is the width of this arrow here, so to speak. So you can see this, you can view this like some sort of an arrow. So the width of this arrow here tells us the number of Napoleon troops. Okay, and here, so what happened here, some of these are branching out. So some of his army is branched off elsewhere. So this number of soldiers, they did not go all the way to Russia. So for some reason they got reassigned or whatever. Okay, so they disengaged for the main troop here. This one also. So there's again there's a fraction of the troop that is reassigned somewhere. And you can see that the width of the line decreases as we go from left to right. So from left to right, this is actually month, okay? So this is sort of like a time series data from here to here. So this is time 0, that's and this is when they reach Moscow, okay? And you can see the number of soldiers were dwindling as they reached Moscow due to sickness and other things, other non-combat related, okay, attrition, okay. So even before the battle started, the number of forces already dwindling on their way to Moscow. And here they engaged the Russian troops here, okay, and the black curve describes their journey back to France, okay. So, and this is actually when they were on their way back to France, they have to confront the Russian winter. Okay, so I think if I remember correctly, they leave sometime in the summer or in the spring, I think, and then they return in winter. So again, you can see what the effect of weather had on the number of soldiers. So ultimately, this is the number of soldiers returning home to France. Okay, so that's don't do war, and it's absolutely necessary. Okay. All right. Any questions? If not, I'm dismissing the class, and we'll meet next week. Thank you very much.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you very much, sir.
Thank you, sir.
Thank you, sir.